Okay, critical path analysis and scheduling problems. These are tricky problems. Watch them more than once. I've had to do a lot of takes to get these videos done for a very good reason. They're tricky and easy to make mistakes. So watch it more than once, if not just to make your favorite teacher get lots of YouTube dollars. So this question asks, how many of these activities could be delayed without affecting the minimum completion time of the project? And a rough translation of that is, how many activities are not on the critical path? That's what we're trying to work out. Now you could do this the long way or the short way, but basically you can just test out each of your paths, but we know K is on the critical path, so we can just ignore K. Now let's do a quick check of this red path. That's 3 plus 7 plus 10, that's 12. Let's try another path. Let's try this green path. If we try that, that's 4 plus 2 plus 2, that's 8. This looks slow, but if you're doing it yourself in the exam, it'd be quicker. This is 4 plus 5, that gets me 9. Let's try a purple one. Like this, 4 plus 6 plus 2, that is also 12, significant. And then let's do this orange one, 4 plus 1 plus 2, that's 7. So if we look at that, we can see there are two critical paths because they're both 12. That's the red one and the purple one. And so from this, we can see that E, I, C, and G are not on the critical path. So the answer is B, 4. Just reminding you that K we didn't include because it's going to be on every single one of those paths, no matter what color. Now, if you've seen my previous videos, and of course you have, you might notice that I've criticized the technique for critical path analysis, because normally what you do is you look at all the ones that have equal numbers, and that means they have 0 float on them. Now we do know there's two critical paths because of these little red zeros, which they don't often talk about. So we know there's a critical path that goes like this, and another one that goes like this, and goes through K as well. But when you look at this, it looks like E at the beginning only has 4 and 4, which says it has no float, but we know there's a difference of 10 and 6 here. There's quite a big float on that. So E does have a float. It's not on the critical path, but it doesn't show up in the figures. And you can say the same thing about I. So if we look at this one, again, we got 4 and 4, and then we got this 12 and 9, which shows there's a float, but it doesn't show up at the beginning of that. When the textbook always talks about these things, they'll often talk about the fact that, say, for example, you've got 3 things coming into the start, so you should do 3 boxes, but you should have done 3 boxes around here as well by the same logic. And that's one of the flaws in the system. If you follow my steps and my understanding of it, you'll probably more likely get the right answer. But again, it does show that B, 4 is the answer. Now again, with these questions, of course, forward and backward scanning is going to be useful. So often just pile in there, get it done, and you'll be fine. And that's what it looks like. Please pause the video. Check my numbers. It's quite like I made a mistake. Far too likely I've made a mistake. I normally do it when I've got a classroom of students looking at me. Now part A is determine the earliest starting time for activity, it says in hours, for activity I. Here is activity I, and the EST is that. Remember, the green box is the EST, and we take the one at the start for the number. So our EST for this is 10 hours. Don't forget your units. Now it says the minimum completion time for the project is 15 hours. So well done, we got 15 hours. And it says write down the critical path. Again, we highlight all the ones where the numbers are the same in my beautiful, neat, clear handwriting. That's definitely a 13, so don't complain. And there's 2's, not Z's. So if we follow down the 0, we've got the 0 here. If we follow that down, we find that the critical path looks like this. Again, there is that problem. I call it the triangle of death, a bit over dramatic, I guess. But you see, we've got this triangle, and that path is 5, and this one is 4, but it's not really showing up here that saying that I has got no float. There's definitely a float of 1 on that, and I'll talk a bit more about that in a minute. But there it says, for the moment, write down the critical path. So the critical path for this case is B, E, G, H, J. Okay, so now to find that 2 of the activities have a float time of 2 hours, we've got to find what those 2 activities are. Now, we said our critical path was like so. Now, this means we've got some other things that are not on the critical path. So that is not on the critical path, and that has a float time of 1. We know that because this is 5 and this is 4, and the difference is 1. So it doesn't always show up these things. But let's have a look at something else. If we were to take this path like so, we can see there is a float time of 1 here. So float time of 1 on that loop. So anything on that loop can have a float time of 1. So D or F can have a float time of 1. But we can also do another thing that goes from the critical path and back onto the critical path. We could have gone that way. And we can see here we got a float time of 2, which is exactly what we want, and C has a float time of 2. Now technically anything on that path can have a float time of 2, but we already said F can only have a float time of 1 because it's also on the green path, because there's 2 paths going through there, the blue and the green. So the only other activity that's left with a float time of 2 is the A, and we can see that it hit also because we've got a number 2 there. So a float time of 2, the answers are A and C. But again, it cannot always be that obvious if you don't realize that float times apply to all sections of a loop until like it bumps into another section. Now this one's a bit of a doozy. Sorry for the small writing, but I have to squeeze everything in. It says that we're going to do exactly the same thing, but with 1 extra activity added. And this activity will have a duration of 1 hour, an EST of 5 hours, and a LST of 12 hours. So if we look at this, if it's going to have an EST of 5, there's only 1 5 in the EST basket. That's the green ones. Remember, green is EST. So it's got to be starting from this node, all right, which is the end of activity E. So we know already half of it, but we've got to get both things right to get this whole thing right. Now, can we take this and go backwards, or why would that doesn't make sense? So we can't do that. So we need to be going forwards. Can we go forwards to this one? No, because we need a dummy. Can we go forwards to this one? No, because it says it's got to join up at the start of another activity, and that's joining to the finish, not the start of another activity. And if you work it out and just pause and have a look, you'll find that the only place to join it up in a long wiggly line is here. So that one will have a weight, we'll put another arrow on there and give it a weight of 1. Now, if we do a little bit of our revision of our forward scanning and backward scanning, we want to find out the LST, and it's supposed to have an LST of 12. Well, if we look at that red number of 13 here, and we take away 1 and go backwards against the arrow, we get a 12, which is exactly what we wanted. So it does look like it makes sense that the end of the activity is J. A little bit tricky, but often with these things, just trial, like, if you've got to join one thing to another thing, try out a few joins and see if they make sense. Suck it and see. It will really, instead of just staring at blankly, it'll help you a lot. All right, so here's another one. We've got a classic 2-question one-off. There's one diagram, saves them having to draw many diagrams. This is quite complicated and messy, but we have to do forward and backward scanning again. Okay, there's all my forward and backward scanning. Don't forget to pause the video or replay it many, many times to increase my view count, because I know you love to do that for me. We want the EST for N. So we're looking for the N, and the green number in the box before that is 12. So the answer must be D12. Fairly straightforward, that one. Now, the next one, is asking about minimum time, so we know that's a critical path. Some activities cannot be delayed. The number of activities that cannot be delayed, so that's basically saying the number of activities on the critical path. So how many activities are on the critical path. So basically, what is the critical path? So here's our 0, 0. We've got a 4, 4. We've got a 10, 10, 13, 13, 17, 17. We see this 0 here. We follow that through, and I find there are 4 activities: C, F, H, M. That's 4. Answer C. Okay, again, so we've got to do some forward scanning and backward scanning. There it is, and I really hope I've got all the numbers right. It does get quite messy with these things and quite complicated. And so now that we've done that, let's see what the actual question is. It says, write down the 2 immediate predecessors of activity I. There's activity I. Now, there's a bit of a trick here because that's an immediate predecessor and then the dummy, but you don't include the dummy. If you've got a dummy, you go one back more, and it's D and E then. So D and E. So you can see there's a nice trick trying to throw the dummy in there. Please don't be the person who writes the dummy, because that'll make you the dummy. Okay, the minimum completion time. We know that means critical path analysis, and it says it's 19 days. No, 19. Now it says there are 2 critical paths, and it's given us one of the critical paths is AEJLN. So AEJLN, that's one critical path. Now things on the critical path, it's got to pass through every node normally that has 0 float. That's all the ones with the same numbers where there's no difference between the EST and LST. And we can see that this guy has not been included. So we've got to find a new critical path that includes that. So let's get our highlight out. We know it's got to include A for obvious reasons. And then we're going to still go with E because we've got to go down to that 10. But we can go through the dummy to this 10 and then cross here, up here, and back down again. So our new critical path is A, E. We don't include the dummy. A very good question. Someone asked me that in class. And then I, L, N. I do like the fact that someone asked me that in class. It shows they were paying attention and actually listening to me. And that's the kind of thing you do when you study. You go, oh, do I have to do this? And then you check the answers and go, no. And then you go, I'll remember that for next time. Now, here's a tricky part. It says for part II, determine the float time for F. Here is F. Now in the book, it will tell you, just look at these 2 values, find the difference, and write that is 6 days. But I don't like that. That's not actually really a very good way to work out float, and you'll see it does sometimes lead you to the wrong conclusion. Imagine you've got there's 2 other paths that include F, right? You could go this way, and then you get an 11 and a 17 difference. That is the difference of 6 that we're seeing here. You could also, though, go another path, which is this path, and you'd actually get a difference of 7. So you might think there's a float of 7, but there isn't, because you've got to go of the paths that include F, that's the orange and the blue path, then the one with the lowest float difference is the one that you take. So that's why it is 6 days. I get very annoyed with the books keep telling you that the float time is the difference between the 2 boxes at the beginning, and it isn't always the case. You'll see that in other questions. Sorry for the small writing, I have to squash everything. It says the project could be finished earlier if some activities were crashed. So we're crashing, and there are 6 activities that they say you can crash: B, D, G, I, J, and L. Well, that's a lot of them. So we can crash B, and we've got to find one of these things. D, G, I, J, and L. Now this is quite a tricky crashing one, and each of these crashings cost $1,000 when you do them. Now let's remind ourselves, on the critical path are all these activities, because there's 2 critical paths. So the first thing you do with crashing is think about the critical path, because you should only crash things that are on the critical path, but as you crash more, you might be creating more critical paths. So we've already got 2, we've got to be careful we don't make more. All right, let's just crash L, because it's on both paths, and it's highlighted yellow. And so if we crash that one, it goes down to 4, and this changes that 17 to a 16. So we're going to compare this now, this 16 and this 16 means that we're close to, we've created more than one critical path. So now this orange line, which includes G, is on the critical path because we've got a 16 and a 16. But we've still got more activities we haven't crashed yet. So let's crash them. Now, on our old critical path, there were 2 things we could crash. We could crash I by 1, and that would make this 11, but that drops it off the critical path unless we crash J as well and make that 11, so that both are 11. That means this is now 11, which means this is now 15, which means now that the orange line is the critical path. Because all the yellow lines are now go to 15 to that point. So now we can actually crash G by 1 to keep balancing this all out, and we make that 8, and this becomes 15. And now we've got 2 15s, and there's no other 15s coming in there because the other one is 11 and another one is 13. So we've got the 2 15s coming into that point, and so we crashed 4 activities. So what is now our new number? So 15 plus 2 will give us 17. So this number is now 17. So our answer is, what is the minimum number of days in which this project can now be completed? 17. Just in case you're wondering about this 18, we crashed down there. That is actually still 17 because the 11 plus the 6 is 17. Quite a tricky thing to do. We'll put days in there just to make sure that everyone's happy. Now we did crash J, I, L, and G. That's 4 crashings. Each one costs $1,000, so that's $4,000. Wow, there you go. Tricky question. Do replay it again, not just for my YouTube dollar account. Okay, guess what? Forward and backward scanning. Okay, so let's start with question 6. The number of activities that have exactly 2 immediate predecessors is J has G and F, and I has E and D. There are no others that have exactly 2, so the number is 2. You can check that yourself. I believe that is correct. The next part is a bit harder to explain. There is one critical path for this project. Let's check. These are all the ones that have no float, therefore they must be on the critical path. And we've got a 0 here, so we're going to go through here, up here, down here, and along here. So there we go, we got our one critical path. But then it tells us no, there's not one critical path. There are 3 critical paths if you change some of the activities. We've got a few changes we can check here. So before we go any further, let's have a look at some other possible paths. So this one goes up here, leaves the critical path, and then rejoins the critical path. This one leaves the critical path and then rejoins the critical path. This one leaves the critical path, then rejoins the critical path. There's one other activity, G, but that's not really going between critical paths, so unlikely to be the necessary one to answer this question. Now, what is the question actually asking? Let's try one of these changes. So if I were reduced by 2 hours, lovely use of the subjunctive grammar form for you grammar junkies out there. So let's take I and reduce it by 2. So that makes it 2. So this 12 becomes 10. And you can see now we're comparing the 10 and 9 and 11. So actually the blue path is now the critical path. So we have changed the critical path, but we haven't added any critical paths. So that is not correct. It is not A. So we can put a big, it's not A. All right, let's try again. Let's try if I were reduced by 1 hour. So let's have a look at E was reduced by 1 hour. So this is now 4. This then gets reduced by 1, which is 7. And look at that. we've got two critical paths. The yellow and the orange are now equal, so they're both critical paths. So we've got two critical paths, and this 12 goes down by 1 to 11, which means we've got two 11s, which means we've got another critical path. So the orange, the yellow, and the blue are all critical paths. That's 3 critical paths. That's the magic number we were after. So it looks like the correct answer is in fact B. But let's just have a look quickly at the others. If G were increased by 6 hours, so I said G was unlikely. If we increase it by 6, it becomes 7. So 2 plus 7 gives us 9 coming in. So this would actually become 9. And if we then took that 9 and added 2, we'd have 11. That would actually create 2 critical paths, but not 3, which is important. Sorry, get the razor there. Just erase a whole bunch of things there. All right, so that didn't do anything. Let's try the next one. It's always good to check out the other multiple choices to see why they didn't work. K increased by 2 hours. If you increase K by 2 hours, all that happens is this becomes 13. It's definitely the critical path now, but we haven't got 3, so that was definitely not the case of being correct. And then if F were increased by 2 hours, let's take F. We'll find out where F is first, and we increase that. I seem to have deleted my critical path. Let's put it back in there. If F were increased by 2 hours, this would be 6. So this would be 11. And again, we've only added a critical path. We've got 2 11s, but we haven't got anything else. So definitely is true that the answer is B, but quite complicated. You have to consider all the other paths, and you're trying to make other paths the same length as the critical path. Guess what? Forward and backward scanning. All right, hopefully I've got all those numbers right. Answers in the comment sections below. All right, determine the earliest start time for activity M. This is M, that's its green box for earliest starting time, so the answer must be 11 days. Did say days up here. It says the minimum completion time, that's critical path analysis, is 15 days. We got 15, so that's all good. And now it says write down the critical path for this project. So here's all my numbers that are the same. And here's a 0, so I know I've got to go through that one, and it goes like that. Now this is what annoys me again, because this 4, 4 here suggests there's no slack on D. There is slack on D, and we can see it because we've got 9 here and 10 here. We've got a difference. There is a slack. So D is not on the critical path, and so we know the path is A, E, I, K. But again, this idea that these boxes are perfect and work every time, not true. So that's our critical path. And it says which activity has a float time of 2 days. Now this is quite a bit of a doozy of a question. Let's have a look at a few things. So we already said before that this has a float of 1, and we know that because we've got this 9 and the 10. So it can't be D. Then if we look at the whole length of this middle path, that has a float of 1. There's no other deviations, and there's a difference of 14 and 15. So that has a float of 1. So everything on that green path has a float of 1. This is where it gets a bit tricky, so pay attention. If I follow this light blue path, like so, you can again see they've got a 15 and a 14, so we've got a float of 1 on the blue path. Pay attention, because there's a float of 1 on the blue path, but if we then compare that to the purple path, the purple path actually only takes, if you go 1 plus 9 plus 3, that gets you a grand total of 13, which means you've got a difference of 15 to 13, Purple wasn't the best choice for that, but that's actually giving you a float of 2. Now, what is the only activity that is on the purple path and not on the blue path? Which is that activity? The only one is H. So it is H that has the float time of 2. So you see we contemplated all the possible paths, and it's quite hidden here. And again, I'll show you that that box thing doesn't work for identifying float, because this one only has a float of 2 for H. But that's not just for H, that's the float for G as well. So it doesn't work just to always look at those boxes. Contemplate the whole path. Now this is a crashing question, and it's talking about, sorry, I have to squeeze everything on here. We've got to have activities E, F, G, I, and J can all be reduced by 1 day, and we've got these different price variables. All right, so I'm just going to remove that now, so so we can see what we're doing, and then bring the question back. So we're looking at crashing. So this is our critical path, remember? So normally when you try and crash things, you try and crash the things that are on the critical path. But also remember what we said, that this only has a float of 1, so there's 9 and 10, and that's going to be important. So when we're looking at crashing this, we've only got a float of 1 on that orange path. So we could crash E by 1, that'll make that 3, this would be 9, and now the two 9s are equal. We've got 2 critical paths, and no further crashing is useful. But we could have had another option, which was to, instead of crashing E, we could have crashed I and put that down to 1 and have the same effect. So we have a choice of either E or I being crashed by 1 before we run out of space. Now that means we can't actually crash. F, G, or J, because that would change the critical path more than we can. And it's all because we're controlled by this D only having a float of 1, and we can't crash D. So back to the choice of E or I. Which one are we going to crash? Well, let's look at our costs. E costs 3,000. I costs 2,000. I don't know about you, but I'd rather only pay 2,000. So what is the minimum cost to complete the project in the shortest possible time? It is $2,000. That was quite a tricky question. Okay, so we've got exactly the same situation, but with the addition of one new extra activity, which is called N. It's going to take 6 days. It's a float time of 1 day, and we'll finish at the same time as the project. Now that last bit means that it's going to attach to the finish. So where could we attach from? Well, you might think we can attach from anywhere, like this or like this, but we can't, because that would require a dummy. So there's only 2 places we can attach from. And again, with these questions, just try out a few things and go, oh, that doesn't work. So often people give up on these questions. That's a bit silly. If I attached it from here, this would be n, 6, or I could have attached from here, and that would be n, 6. So we've got 2 choices, which one is the correct one. And the key factor here is this float time of 1 day. So if I was to go, say, around here like this, that would take me 7, which is 1 more than 6. So it looks like we do get a float time of 1 here. But if I go this way, that takes 9. So the difference between the 9 and the 6 is 3. So the bottom one has a float of 3, so it can't be correct. So the correct one is this top one, because it does have a float of 1, the difference between the 2 paths. So if you add the activity N to the network, it must go like we've drawn. Then it says, what is the latest start time for activity N? Now, if we follow through, remember we said that was the critical path. So that whole thing takes 4 plus 4 plus 2 plus 5, 15. 15 minus 6 is 9. So the LST, remember, is that red number when you calculate backwards. So the answer is 9 days. And if you were to go forwards, that makes more sense, because to get to this point takes 8, and you've got a float of 1. So 8 plus a float of 1 is also 9 days. So that also makes sense if you went forwards from that. Again, you might want to watch these videos a few times, not just to get your favorite teacher's view count up, because he would like that to be up, and he can get all those amazing YouTube dollars. But these things are not easy concepts. Watch them more than once. If you're getting this from watching this once, well done. Better than me.